This is a power generation example. Now, we're using a motor here. It's actually a Lego motor. A motor is simply a device that converts energy between electrical energy and mechanical energy. So the motor, if we give it power, electrical power, it converts it into mechanical energy. The other way is if we turn it, so it's using the same device, but if I turn it, I can create electricity. So this is how we're using it as a generator. In this case, I want you to turn the wheel, and try to do a consistent manner so that you just see the light turn on very dimly. If I turn it faster, I can get a brighter light here. If I switch this over to an incandescent bulb, this is an LED bulb that we just saw. If I switch this over to an incandescent bulb and try the same experiment, turn it to where you just see light, you find it's a lot more difficult. And I have to turn it a lot more difficult. So the light is just turning on. You can barely see that. But it takes a lot more effort on my part. And that's because incandescent bulbs are a lot less efficient than LEDs. And that's why people are using LEDs for a lot more light applications than they do nowadays for flashlights and billboards and traffic signs than the old incandescent bulbs. They're just a lot more efficient. Now this board is built with 3 contact points. If we use this one and this one, we contact them up to a digital voltmeter or a MIDAC to measure the voltage across here. That would tell us what the voltage is that is generated by the generator. This other contact here, if you connect this again with a voltmeter, the MIDAC, or a digital multimeter, you can find out what the voltage is across this 10 ohm resistor. Now this resistor is in series with these light bulbs, with the light. And so if I measure the voltage across this resistor and divide by that resistance, so I'd have this voltage divided by 10 would give me this current. This current through the circuit times this voltage generated would give me the power, because power is voltage times current.